Have you ever stopped to think about how your phone, your laptop, and maybe even your smart TV all manage to connect to the internet? I mean, they're all made by different companies, yet somehow they just work together. Well, it's not magic, it's more like a language. And today, we are going to pull back the curtain on the hidden rules that let all our devices communicate.
So let's just frame the big question right here. How is it possible? You've got billions of devices out there. iPhones, Androids, old Windows PCs, smart fridges, you name it. How do they all speak the same language to get online and talk to each other? What's the secret sauce here?
Well, the answer is a standardized set of rules, or what we in the biz call networking models. You can think of them as the universal grammar for the entire internet. It's what makes sure every single device is playing from the same sheet of music.
Okay, so let's start with the big one, the granddaddy of them all. This is the perfect theoretical blueprint that kind of started everything, the OSI model.
Now, the big idea behind the OSI model is its 7-layer framework. Each layer has a very specific job to do, and here's the cool part. It only talks to the layer directly above it and the one directly below it. It's this super clean division of labor that makes the whole system possible.
So let's build this thing together, right now from the ground up. At the very bottom, you've got layer 1, the physical layer. This is the stuff you can actually touch. The cables, the connectors, the radio waves from your Wi-Fi router, it's the hardware.
All right, building right on top of that physical hardware, we have layer 2, the data link layer. This layer is all about getting the data formatted just right for that physical connection. And, super important, it checks for errors to make sure the data arrives in one piece.
Next up, layer 3, the network layer. You can think of this as the internet's own personal GPS. It's in charge of addressing, like IP addresses, and routing, which basically means it finds the best, most efficient road for your data to take across the entire internet.
Then we get to layer 4, the transport layer. This one's job is all about reliability. It makes sure your data gets where it's going and that it gets there in the right order. It does this by breaking big files down into smaller, more manageable pieces called segments.
Now for layer 5, the session layer. This one is kind of like a conversation manager. It starts, manages, and then ends the connection, the session, between two computers. It's making sure that the dialogue starts properly, stays open as long as it needs to, and then closes cleanly.
We're almost there. Layer 6 is the presentation layer. You know what? Just think of this as a universal translator. It takes the data from your app and puts it into a format that the network can actually understand. It handles things like encryption and data compression too.
And finally, at the very top of the stack, we have layer 7, the application layer. This is the one we actually see and touch. It's your web browser, your email app, your favorite game. It's the part of this whole incredible system that's built for us humans.
Okay, I know what you're thinking. 7 layers? That is a lot to remember. So how do you keep it all straight? Well, there's a classic little memory trick. Please do not teach students pointless acronyms. That gives you physical, data link, network, transport, session, presentation, and application. It's a neat little trick for a pretty complex system.
But, and this is a really important but, while the OSI model is this perfect, beautiful blueprint, it's not actually what the internet runs on today. So why not? Well, it was kind of a case of bad timing. The toolkit that actually won out was simpler, it was developed earlier, and you know what? It just worked. And that toolkit is the TCP/IP stack.
Yeah, this is the real workhorse right here. It was developed way back in the 1960s by the US Department of Defense for a project called ARPANET. And this is the protocol stack that powers the internet as we know it. This is what's happening under the hood every single second of every single day.
So now we've got these two models on the table. On one hand, you have the 7-layer OSI model, our perfect conceptual blueprint. And on the other, you have the 4-layer TCP/IP stack, the practical, get-it-done implementation. It really is a classic case of theory versus reality.
So let's actually put them side by side. Let's see exactly how that perfect blueprint maps onto what's really happening out there on the internet right now. So you can see the difference right away, can't you? The TCP/IP stack is just more streamlined. Look at the top. The top 3 OSI layers, application, presentation, and session, they're all just squished into one application layer. Same thing at the bottom. The data link and physical layers are combined into one link layer. It's a leaner 4-layer model. But the core functions of the transport layer and the network layer, which is now called the internet layer, are still there and they're just as important as ever.
So why do we even care so much about these different layers? Well, because understanding what each one does is the key to understanding how the entire internet actually works. So come on, let's pop the hood and take a quick look at what these most essential layers are really doing.
First up, the transport layer. Okay, imagine you're mailing a huge, heavy book. You wouldn't just try to cram it into one giant, flimsy envelope, right? No way. You'd break it down into chapters, you'd put each chapter in its own separate, numbered envelope, and then you'd mail them. That is exactly what the transport layer does. It breaks big files into small segments for a reliable trip.
Next, the network layer, or, the internet layer in the TCP/IP world. This is your data's personal GPS. It uses those logical addresses, like an IP address, to figure out the absolute best, most efficient path for each of those little data packets to take across the gigantic, complicated web of the internet.
Right below that, you have the data link layer. Now, this layer's job is to get those data packets ready for their actual physical journey. It gets them formatted correctly for whatever connection you're using, whether it's an Ethernet cable or Wi-Fi, and it adds a final layer of error checking to make absolutely sure that what arrives is exactly what was sent.
And finally, connecting it all to the real world, you have the physical layer. This is where the rubber meets the road, so to speak. This is where it all becomes tangible. We're talking about the copper cables, the fiber optics, the radio signals, the actual electrical voltages. This layer is what turns all those digital ones and zeros into real physical signals.
So, what's the big takeaway here? What should you remember from all this? It's that this layered approach is what makes this impossibly complex global network of ours manageable. You have the perfect 7-layer OSI blueprint on one side, and the practical 4-layer TCP/IP stack that actually runs the show on the other. This whole structure is the key. It allows for open standards, so different companies can build things that just work together. And it makes finding and fixing problems a whole lot easier. So, the next time you click a link, send an email, or watch a video, just stop for a second and think about it. Can you picture that incredible, lightning-fast journey your data is taking? Down through the layers on your device, zipping across the globe through a maze of cables and routers, and then back up through the layers on the other side? All of it happening in the blink of an eye. Pretty amazing, isn't it?